All right, good evening, YouTube. Time for another academic paper with me, Tobin Martin. And we're going to go into LSD-25. What's today's date? It's like 3, 4, 26, so 10:08 p.m. All right, so let's just go into a quick, brief history of LSD. And so some of you already have heard of this guy, but Albert Hofmann is known as the inventor and discoverer of LSD. And what happened is in April 16th, 1943, he noticed the first psychoactive effects were noticed. I believe he came into contact with some of the material while making some amount for other research. And so and that's how he first noticed that it had some effects. And so April 16th is a noteworthy date, but then there's also April 19th. That was when he first actually took first dose of recreational use. And it was known as Bicycle Day. And so because he had to, he took a much larger dose than simply contacting his skin, and then had to go home and ride it out. It dilated his pupils. It caused a bunch of other psychoactive effects, and this of course was later renamed for Bicycle Day because of the time he rode his bike home because of those effects. But here I'll take a second to draw the molecule here because the physical structure of it is going to become important. Let's see, let's start. This could take a second, but you gotta take a second to draw these. Otherwise the presentation would go too fast. So here we go. Take a little phenol ring out here. I have to kind of work with the tripod in the way, so my handwriting is a little bit trouble. This is I'm noticing now. So, double bond there. Let's see here. Okay, and then let's see. Amine group out here. Let's double bond it there. All right, so I'll go ahead and add a couple of designations to. Whoops. Just, a little bit taller here because there's another carbon hiding there. The end is just a little bit too tall. You know how it is. Let's see, and then so this of course is the indicating that this connection is coming out of the page. This one is going into the page. So we have a double bonded oxygen out here, and then some nitrogen. Oops. Oh, there we go. And then let's see here, and let's see, this is going to have an F group on it, and then so is this one right here. Okay, so this is of course LSD, LSD. For the two chiral centers, which is going to be this carbon here is carbon number 5, and then this carbon over here is carbon number 8, and both of these are a R configuration, which is Latin for rectus, meaning right-handed. And if you study organic chemistry, you will know we just indicate those as R's. So this is also R. The other carbons also have a numerical designation, but we won't have to worry about those at the moment. So how does this actually play into our understanding of acid? So I think it has something to do with something I like to call quantum polymers. Something I've made up. It's just one of the things that you struggle with and try to understand, but it's like that's the first thing I came up with when trying to describe its activity. And so we know from other parts of organic chemistry that chiral centers tend to form monostereomers, but also in the case of a dual chiral center like this molecule here, you can also form diastereomers. And so supposing you took a mixture of RR-LSD mixed with nothing else, what if you could have a stack of these that could be built up just by these monostereomers or these diastereomers forming? So I'll say let's start this down. So is it IOER or something, whatever? monostamers and but yeah, so monostamers are the quantum polymers that are formed, often dimers, of single chiral centers, and diastereomers are the same phenomenon, but for a two chiral center configuration. And so my hypothesis is that in the synapses, if let's pretend we have a synapse protein like this, and it had a little binding site for the LSD molecule, you could have your R's, just do up arrows, right, for now. So the three functional groups of this acid molecule, which is just drawn as a plane, what if they be orienting up, and then what if you had a second one on top of it that also is orienting up like this, forming diastereomers. But what if you keep going? It's like, what if there was another synapse upward here and had another socket as well? And then you could have some talk back, or crosstalk between these two synapses. Something I call pathway entanglement, because it's the path between two synaptic connections, probably formed by diastereomers. And so it's like, I call this effect stacking, at least I hypothesize that that's what it'd be called. And I also use this maybe as just a estimation as to what it would actually be, but it would give rise to vertical thinking. Lateral thinking is usually kind of like a sidestep, right? But it's like vertical thinking is less think of it as, say, like creativity, for which this drug is known. But yeah, so now we have this idea that we can link up multiple acid molecules together. What are some other effects if we include other configurations of this particular molecule? And so let's talk about stacking, branching, and socket orientation. So given the mechanical nature of the brain to have sockets like this, you'll notice that this molecule is not like a little double diamond diagram like it is down here, but it actually has a bit of a shape to it. It's kind of a oblongness to it. So this binding site for this nitrogen is over here. It's got all this phenylalanine over here and a bunch of other bits of carbon and other stuff in the way. So it's like, okay, well, suppose we had other configuration, so different mixes. So let's see, mixes. So mixes, and then versus racemates. And then we'll get to what that means in a second. So suppose we had a mix of so RR plus SS, and so suppose we had these two flipped. So these would have this carbon would be going, this line here, connectivity would go out of the page, this one would go into the page, and suppose we had one that was 5R, 8R, and then also mixed together with 5S, 8S as its two chiral centers. What if that caused a different stacking effect? Because what if this is actually wrong, and these things actually prefer to link up going the other direction, and one actually has to alternate? And so what if the vertical thinking effect actually is increased by having a mixture of these two optically pure preparations? So optically pure preparations do not have a quantum entanglement of a shared reaction vessel as they do for racemates, so or racemic mixtures. And so I imagine if you did a mix of two optically pure, you'd probably have some stacking, but then that stacking might be subdued or it might be blocked. I'm not actually sure because I've never done it. I'm pretty sure the only thing I've ever done is double R pure. But that being the case, it's like, okay, well, suppose we did that and then we had increased effects, then it's like, okay, they probably alternate. And if you had decreased effects, they probably just cancel each other out. TBD on that. I don't exactly have a chem lab in my dad's house here, so it's like, oh yeah, we'll see about that someday, maybe. But so we did this with a racemic mixture, where these form diastereomers with each other, but because there is another degree of freedom forming the same reaction vessel, there might be some flutter between the two of these because of the quantum entanglement state. So like in that case, I bet you this effect would be either completely eradicated, like they would have too much flutter to form any diastereomers, or it'd be greatly increased. So imagine that if you add the effect of having these two configurations put together in some way in the same reaction vessel, you could possibly have increased psychedelic effects. Although I'm pretty sure that you only can do forming one of the chiral centers at a time, but it's like supposing we did a four-way racemate where we had RR plus SR plus RS. The idea is that if you did a racemate mixture, we just eluded these two out somehow and did not include an SR and an RS, that would have vertical thinking effects that would probably either intensely disinhibiting or basically nothing at all. It's one or the other. I assume it's very polarizing. But let's talk about branching for a second. Suppose that we actually had a mixture that had a bunch of these SRs and then a bunch of these RSs, and then I'll just only assume that's a mixture of optically pure preparations that were, each of these were made in separate reaction vessels, mixed together, put on a blotter paper or into a gelatin, and then taken by somebody. And so that would have some sort of, that would be lacking a quantum entanglement state. And then, but if we think about the socket orientation, what if we had movement of these things to go like this, and they tend to go, had R's and S's, so this would be like an R, this would be an S, this would be R, and this would be S. You'd have a branch going off to the right, and then if you had the other orientation having S's and R's, you'd have a, so they go down here and then up here. This is going to go up and the down of these connectivities here. This would be a this would be an S and this would be an R. They branch the other direction. Supposing our synapses had some sort of orientation to how these are rotated, supposing they're close to the outer cortexes, or at least as they are in the occipital lobe, you'd either have direction going towards the visual effects, so towards something more psychedelic, and then maybe this is going backwards towards the back of the brain, towards the cerebellum, and maybe to be more facilitating of dancing. And taking acid and dancing is a greatly enhanced and fun experience. It's like I highly recommend it. But the point is that supposing the idea that these sockets have an orientation, a actual mix of these enantiomers, at least this one, plus these two, or if just one of each, it's like you could have a three-way mix, a four-way mix, or just two different two-way mixes, and I bet you all these would have psychedelic effects. I'm assuming that RR is the one that binds most readily to start off your foundation if for these branching and stacking effects between two synapses. But yeah, suppose that one of them branches this way, and then it has, it's more visual, and this one branches that way, is probably more like a body high or something like that. Anyways, supposing that we actually did that instead of doing a mix of optically pure preparations, we did this with racemates, and so I'm not really sure what the recipe is, but supposing you actually had a quantum entanglement state where you're making one of these chiral centers, let's just suppose it's the 8 right here for 8, and suppose that you had this one as a as part of your racemate, you'd probably have greatly enhanced psychedelic effects, because we know that these quantum entangled molecules tend to talk back to one another. And when they talk back to one another, you can have a greatly shared activity of either nearby synapses or probably something I like to think of as conduiting. It's like, what if energy, when you bump this electron cloud over here, if all these electron clouds are tied together along this branch, it's like, what if it set off a whole bunch of other synapses at the same time? So you'd probably get repeating patterns, kaleidoscoping rotations, melting, or other sort of optical illusion type effects. And it's like, so suppose that were the case, what do we call it when you bump this one electron that's hanging out at the foundation, and then it was shared between multiple people? And it's like, that would be something I like to call flashback momming. And so I noticed that when taking acid with my friends, if you happen to have a shared experience and if someone thinks about it, everyone else in the group also thinks of the same thing. And it's like, while you don't notice every feature of that visual experience, because it's usually pretty subdued when you're just doing RR, double R pure, but it's like you can actually kind of facilitate the cohesive memory of the greater group if you are taking it together. So flashback bombing, and then pathway entanglement. So the pathway entanglement is literally the ability to think of a memory. You can actually run it forwards or backwards, and then this idea that you can actually think of it and have everyone else in the group think of it, I like to call pathway entanglement. But yeah, so supposing that were the case, and so how do we describe this for, these are mostly not going to be used for most of this, the most common preparation, double R pure. Suppose that we still have shared memory type experiences or pathway entanglements. How do we explain quantum entanglement of a quantum entanglement of a optically pure preparation? So you know, based on this diagram here, that this particular molecule does have a relief to it. I've made L-wire candy art there that this is clearly going out of the molecule, and then, or so going out of the pane of the perlers, and then this one similarly has a depth to it. And so we have an achiral, or sorry, it's not achiral, so we have a no entanglement state, but we still have quantum entanglement properties for something that's optically pure, which we know not to have the degrees of freedom to have quantum entanglement or some sort of linked shared chiral formation. But it's like, one more thing to add to this mix, so that when you think about that socket, supposing that we have a three-dimensional feature here, you still have this electron cloud that can overlap with it if it's bound down to on the binding site, right? So that is what I call the quantum entanglement of a chiral formation, which is a three-feature socket, which has a fourth functional group of nothing and a virtual chiral center. So if you did that at the same time with other people, those probability clouds would be overlapping in time, but then also still have the necessary electron density and degrees of freedom to actually have some sort of quantum entanglement state, even though we had something that had no quantum entanglement state to start, and which also means that it would work after the acid is purged away. So it's like, we know this tends to only last in the body for a little while, temporary in fact, but whatever is left in that socket on that path of entanglement might still retain a quantum entanglement state even after the branches and stacks have long dissolved away. So with that in mind, let's talk a little bit about the exponential tolerance curve. So unlike the other drugs, when you take LSD, your body downregulates its activity by a huge amount very quickly. It's like, means that you have to take a lot more every time you do it in a short amount of time until your body is reset from doing so. So this is something that's kind of like a Fibonacci sequence. So if you take one at the start, and then the next time you basically have to take the entire cumulative dose of all those previously. So the first one you take one blot or one gel. Next time you take two, then the next dose, then you take two like this, and the next one you would take between 3 and 4, say. And that can get very expensive very quickly. But it's like, you can't have fun in 12 hours just off one. It's like, oh man, you probably didn't plan it out carefully. But it is definitely known as one of the least damaging, lowest hangover type drugs, maybe non-existent, maybe even exciting the next day, even after the effects have long worn off. But yeah, I've heard different figures for how long it takes in between acid trips for your body to reset, as little as 3 days, but most people tend to do it months to years apart, let's say for like festivals every year. And then, but yeah, it's like the one and done, the one hit wonders are definitely a thing. It's kind of like a less is more, because honestly, being too discombobulated, even on RPR, which has very subdued psychoactive effects and very mild hallucinating effects of the vision, it's basically, it's like if you plan your things out, it's like only 1 or 2 doses seem to do a person right. And that tolerance while goes up exponentially on the local acid trip. On the overall acid trips, one and done seems to apply well after you've been doing them to the point where you have expressions like, ah yes, if you add it all together, for me it would be a drop in a bucket. So but let's talk one more thing. So NBOM mimics, the NBOMEs. It's like you'll notice that these ones do not luminesce under UV. And so NBOMEs are known to have basically cause feelings of drunkenness pretty rapidly. They do not glow under UV, unlike acid does. And they also are known to cause strokes. So it's like, all right, check your stuff with the black light, and then make sure it's not just, make sure that it glows under that. It's just a basic test. And then also, one more, Ulrich reagent. Your typical marquee reagent and mech reagents, while you could possibly use them on powdered acid, and that would usually be an amount of acid so great that you probably have a GCMS or an LCMS in your backyard at the same time. Ulrich reagent can detect acid, I think by turning purple. I've never actually done it myself, but I know it to be separate from the typical reagent tests. And that can help you determine if you have acid or not, if you don't have just the simple litmus test of doing the UV. Litmus test, of course, is figured expression. If you do look it up, litmus test is very specific for indicator paper. Anyways, but yeah, Ulrich reagent can help you determine if you have acid or not, usually if you have white on white paper. But yeah, it's like I just wanted to talk about acid for a second. I think that just about does it, so cool. Anyways, token out.